here we go. Rushing through these bad boys. I mean, you had to see this coming, I hope, if you did some free response with your teacher leading up to this. They asked this question so many times. They're talking about f, which is this graph here, and then they tell me, oh, by the way, there's this function g, who's the integral of f. And all that means to me is that this graph is really g prime, okay? And the fact that I'm starting at 6 also tells me that g of 6 is 0, okay? Now, g of 6 is 0, not because of this point here. That's g prime. So g prime of 6 is also 0, if you're paying attention to what's going on. Okay, because f of 6 is 0. Okay, so they both happen to be 0. A says find g prime of 8. Give a reason for your answer. Okay, so A. The reason for your answer is going to be that g prime of 8 is just f of 8. And they want to see you show that. Okay, so g prime of 8 is just f of 8. This is a graph of f. How nice. F of 8 is that point right there. That just equals 1. B. Find all values at which g has a point of inflection. Well, we did this a bunch in class. Inflection points happen when the graph of the derivative, so inflection points on g happen when g prime changes from decreasing to increasing or increasing to decreasing, or another way to say that is maxes and mins. So there's one here at -3, there's one here at 3, there's one here at 6. But we got to lump them together in how they change. So we got to say how they change. So I might type this out because my handwriting is sloppy, as you can see. Man, I should have added my face to this video so y'all can see what I look like. It doesn't really matter. You're missing out. All right, here we go. So you should be saying at x equals, I'm going to lump together -3 and 6. -3 and x equals 6. Because f of x, which equals g prime of x. You don't need to say that because I set it up here, but that's fine. Because f of x equals g prime of x changes from, decreasing to increasing. So g double prime of x changes from negative to positive. That's one answer. Also, at x equals 3. Because g prime of x changes from increasing to decreasing. So g double prime of x changes from, you know where this is going, positive to negative. That's what they want for B. For part C, it says find g of 12 and g of 0. Okay, no problem. So I know that g of 12 is the integral from 6 to 12 of f of t dt. Luckily for me, the integral from 6 to 12 is just this triangle. Cool. So the integral of f is the change in its antiderivative, which I don't know, but it's also the area between it and the x-axis. So that's this here. This is a triangle with a base of 6 and a height of 1, 2, 3. So I'm going to say, hey, College Board, this is 1/2 times 6 times 3, which is 9. And for g of 0, we would say that's the integral from 6 to 0 of f of t dt. And you don't have to write this part, but I like to switch these if I'm integrating backwards on a graph, because I sometimes forget to change the sign. So it's the same thing as this. It's just the area in there, but it's the opposite because we're going backwards. So this happens to be a semicircle with a radius of 3. So, I heard some people say 9 pi over 4. That's very good, okay? So the area of the whole circle is pi r squared, which is 3 here, so that's really 9 pi, but over 2, not 4. But you're dividing that by 2 because it's a semicircle, so it's negative 9 pi over 2. All right, and then D. Find the value at which g attains an absolute min. I'm so glad they asked this question. I promised my students they were going to ask to find absolute max and mins a handful of times, and here's the second time they've done it to us. But we're going to do our 4 steps for this. Step 1, I need to show that if I want to find the absolute min of a function, I need its derivative, which is f in this case, to equal 0. And then I'm going to solve that. That happens at -6, 0, and 6. Just by looking at that graph, -6, 0, and 6. So that's step 2. Step 3 is find the amount, find whatever we're trying to minimize or maximize here. So g in this case at the endpoints. So I need g of negative 6. I need g of 12. So I got to find those. Okay, we already found g of 12. It was 9. I'll come back to g negative 6, but I also have to find g at these other places if they are possible minimums. So let's look. 0 is definitely a possible minimum because my derivative is going from negative here to positive. So that's a possibility. 6 is not because it's just the derivative is positive and then positive. So I also need to find g of 0. But luckily, they already made me do that. It was negative 9 pi over 2. So all I really need to find is g of negative 6. And that is the integral from, where we're starting at, 6 to negative 6 of f, which is just the opposite of the integral from negative 6 to 6 of f. And that is going to be, is it 0? I think it's 0. Yeah, these circles are the same. So this is positive 9 pi over 2, and this is negative 9 pi over 2. So they cancel out. So this is just 0. And since they're looking for the absolute minimum, we're going to write a little sentence here. To justify my answer, I just did by showing my work. I showed that I found where the derivative is 0, I found those places, and I found the value of g at those places. So we are going to see or say, let's make this, I got to change my defaults on this, yo. Okay. The absolute minimum of g of x on the interval, I forget what they wanted. I.e. negative 6 to 12. Negative 6 to 12 is g of, what was it? G of 0, which equals negative 9 pi over 2. Get out of here. Negative 9 pi over 2. Okay? And then again, I'd still write my little sentence here, although it's not super required. I check the endpoints, and where g prime of x, which just for fun equals f of x, changes from negative to positive. There you go.